Okay, welcome to the session. So in this session, we are going to discuss on the 2D viewing concept in OpenGL. Fine. So now when I'm going to talk about a two-dimensional viewing, so usually when we talk about a viewing operation in OpenGL program, usually we think about these two major questions. So which is going to tell which part of the defined picture is to be displayed. That is, we design the entire scene or we design the entire objects, what should be in the scene, and we are going to decide in this completely defined picture or the defined scene which part, particularly which part should be displayed or the whole scene should be displayed. So we can take a call over there. So which part of the defined picture is to be displayed. And so once we decide what part should be displayed or which part should be displayed, now we will decide where this part, which we are going to pick it for display. So where we are going to put it on the display device. That is what the two major questions what we are going to put up when we are going to talk about a 2D viewing operation. The first question is, so which part of the defined picture is to be displayed and where that part is to be placed on the display device. Now I will just give a clear picture about this, what exactly these two questions are all about and what or how this is going to help me in having a 2D viewing in graphics environment. Now let's look at this. So using the coordinate system, any coordinate system, and usually we call this as an modeling coordinate system. So where we are going to design this few objects, we are having this many objects right now in the given coordinate system, and I call this as my scene. I call this as my complete picture, or this is the picture what I've been defined. Now in this defined picture, so which I am supposed to display is only this part. Fine. So now there are four objects. I don't want all the four objects to be on my display device. This is what of which I want to display now. Hence this is the part which I am picking up to be displayed. And so once I am going to pick this, I am going to have the display device, that is the monitor, the output device. In this monitor I am going to have my graphics window. Now this is the graphics window where I am going to place my object, which the part I have been picked. This is my entire scene. In this entire scene I am picking only this part of my picture and I am putting it on my display window. This is my display window. So when I say I am putting it on the display device, so don't take it the complete monitor as my display device. So this is the part where I am going to put my object. Fine. So now this is what happens in the 2D viewing. So this is what exactly I am saying what I should view or what part of my scene I should make to be visible to the user who is going to use my system. Hence, so later on, so now what happens to this object? So this object will be erased or will be deleted? No, it will be still in my definition. This is still the definition of my picture. The only thing is right now at this point of time, I am displaying only these two objects. Later on, if I want, I can change what part I need to display at this point. So previously I was displaying the triangle and this object. So now I am changing my view and I am displaying these two objects. This is how you can move and you can decide what object you should view. And so now whatever the operation we do, that is from the modeling, which we call this as the world coordinate, what I have been designed the entire scene. Now I am picking what part, I am picking where it should be displayed on the display device. Hence we call this as device coordinate. So from the world coordinate I have placed my object to device coordinate, and this is not just one step operation. I have world coordinate, so convert it to device coordinate. Hence, there is a conversion which happens, or there is a transition which happens from the word coordinate to device coordinate, and it is not again a one-step process. It takes few set of operations, and this set of operation, whatever we are going to have, sometimes I can apply translation, sometimes apply rotation, sometimes I may apply scaling, or I may combine all these things, and even majorly the major operation what with respect to viewing we speak about is going to be the clipping operation. Hence, at the time or in the process of transition from the word coordinate to device coordinate, these are the set of operations which can come into picture. If needed, I may take up the translation, rotation, or scaling, and even the clipping. Now, for example, at this point of time, these are the two objects displayed on the device coordinate, and remaining objects or remaining whatever the part of my scene is going to be, I'm saying I'm clipping it out. I'm clipping it out my view. I'm clipping it out my visible window. That is what the clipping operation is going to be. And so now this is what exactly happens during the translation from word coordinate to device coordinate. And whatever the translation right now we are calling, we call this as graphics pipeline, or we call this as 2D viewing pipeline. Hence, now we will see what exactly this pipeline is going to be, what happens exactly in this pipeline, and how the conversion or how the translation is going to happen from the word coordinate to a device coordinate system. And so now just look at this. Whatever the objects we have designed, the scene, and in this scene, whatever the part I have been tried to pick up, we call this as viewing window. This is the part of the scene which I want to view, hence I call this as viewing window. Remaining whatever the objects I add in my scene right now will be clipped off. This is the only visible objects or visible part, hence we call this as viewing window, the part what I pick right now. And once I have been picked that part, and once I decide this objects will be on my graphics window in the device coordinate, so we are going to call this as view port. I create a port where I can put the data. So right now for me the data is the object of my scene, hence I am deciding this is what I should display, and there is already a space allocated for me where I can view my object, and the space already allocated for me to view my object is going to be the viewport. If there is no viewport, there is no any graphics window. If there is no graphics window, you cannot put the objects what you want to view right now. Hence, when I am going to have a viewing window, you can see these two objects are not displayed. Hence, we say these two objects are clipped off using the clipping operation. Hence, now whatever the view window we are using the view window for the purpose of clipping out the objects which is not necessary for me to be displayed by using the clipping operation. Hence, the viewing window is the clipping window for me. It's fine. And so whatever I have been picked from the viewing window, I'll put it to the viewport. Hence, the viewing window will be controlled by the viewport. Whatever the viewport you define, whatever the viewport you are going to have, that is what the viewing window is going to use and is going to display. If there is no viewport, you cannot display anything from the viewing window to the display device or the device coordinate. Hence, we usually say the viewport is going to control the viewing window. Fine. And so now just remember the two questions which I posed you at the very beginning of this session. That is, which part of the defined picture is to be displayed, or I can say what part of the defined picture is to be displayed. That is what I am doing with the viewing window. Hence, the viewing window is the question which is going to answer what part or the which part I am going to display. And the second question was where that part of a display device. I am going to display it on the viewport. Whatever the viewport it is going to be structured or designed, that is where I am going to display my picked objects or the selected area. That is where the viewport is going to stand for where. Hence the viewing window will tell me what part I am going to pick from my scene. Viewport will tell me where the picked object will be displayed on the device coordinate. This is what the windowing system is. This is what the viewport is. Whenever you talk about a 2D viewing pipeline, so please keep remember this two keywords or these two major operations, that is the viewing window and the viewport. And so now we will discuss what exactly this is going to do in all of my 2D viewing operation in OpenGL program. Fine. So now just look at this particular example what I'm showing you. So right now this is the clipping window, or this is my entire scene. The mountain what I have been designed or what I have been defined as a picture in my graphics system being in the world coordinate. Being in the world coordinate, I have been said this is where the part I need to display now, and this will act as a clipping window, or this can also be called as viewing window. Fine. And the viewing window is also called as clipping window. That is what we are going to have. Clipping window is same as viewing window for me. And so now from this clipping window, whatever the part is going to be outside clipping window will be clipped off. Hence now this will be transferred to the viewport, where we are going to have the viewport coordinate. And whatever is going to be in the viewport, just remember whatever we are going to have in the viewport, this will be directly mapped with your device coordinate in form of pixels. That is the power of viewport in your OpenGL program. And you can just see, you can just look at this example what exactly has happened. One is the clipping operation which had happened. The second, observe carefully, the size of the object, the size of my scene has been decreased. That is, the scaling operation has been occurred. Hence, where I just told you, when they said transition from the viewing window or the world coordinate to viewport coordinate or device coordinate, there is certain operations which is going to occur, the translation, the rotation, the scaling, or the clipping. But majorly when I talk about the viewport, the scaling operation will usually happen, because I need to map the scene what I have been picked with the viewport what has been defined. Hence usually the scaling operation is going to happen, and the scaling operation every time need not be the decreasing one, even it can increase. Even if the viewport is larger area than the clipping window, the size is going to increase. And if the clipping window area is larger than the viewport, the size is going to decrease. If both are intact, if both are same, the size is not increased or decreased, it is going to be unchanged. And this is what the world coordinate and the viewport coordinate is going to be. So clearly understand what it is going to do. And whenever we are going to talk about the clipping window and viewport, just look, it's going to be usually a rectangular shape. It's going to be usually a rectangular shape. That is what we say, clipping window and viewports are rectangles. And the rectangle edges, what I'm going to take now, this edge is going to be in parallel. Is going to be in parallel with the x-axis, even this edge, and these two edges will be in parallel with the y-axis. And that is what we say, the rectangle edges are parallel to the coordinate axis. The same case with the viewport window or the clipping window. This is what you need to clearly understand, what the viewing window is going to be and what the viewport is going to be. So now with this, I just want to put few more points with respect to the clipping window and viewport. Now anyhow I know what the 2D viewing pipeline contains majorly a clipping window and a viewport, and I know these two are necessary for me to pick what I should display and where I should display. But now what is the use? Why I'm doing all these things? Fine. If it exists, how it is going to help me in handling my graphic system or the graphic design efficiently? Just look at this. If you have these two windows, there are a lot of advantages what can happen. I have been listed out few over here. So the change in the position of the viewport can affect the view object at different position. If I change the viewport, that is, if I just reduce the size of the viewport at the part what I want, then I can change the position. Still the clipping window is same, but now I can decide what is the position of the object is going to be in the scene. That is, if I reduce the viewport size and if I shift the viewport wherever I want, the object would have been closer to the origin. By moving the viewport away from the origin, even it's going to move the object away from the position, away from the origin. Hence, by changing the position of the viewport, wherever I'm going to move the viewport, the object will tend to move along with the viewport. That is that the viewport is going to help you out. If I change the position of a viewport, the object position will also be changed. And next, I am going to have only one clip window in 2D view pipeline, but I can have multiple viewports. If your graphic system supports to have multiple viewports, then I can have multiple viewports. The multiple viewports are sections of scene at different screen positions. I can have different section of the viewing clip window at different scenes at different screen position. At the same time, I am going to have multiple viewports displaying different objects of the same scene where I am going to have at the different positions. This is the second advantage of using viewport. And if I am going to have viewport sizes varying, if I change the size of the viewport, then the size of the object will change. Proportion of the object will also change. This is what I told you. Right now, the object size has been decreased as compared to the clipping window. If I increase the area of the viewport, or if I increase the size of the viewport, the object size is also change. Along with change in the position, even now I can either increase or I am going to decrease. Clear? So now, having all these aspects of viewport, now if I am going to fix the size of the viewport, I am not going to change the viewport size. But now if I am going to have different size clipping window, right now I am going to keep the viewport constant, changing nothing in its size. But now I am going to vary the size of the clipping window. If I compress the clipping window to this area, it appears like I am zooming the scene. And if I enlarge the clipping window to this extent, it looks like I am zooming out. That is, the viewport is same, but the amount of object what I am putting into the viewport will change. Hence, by varying the clipping window, I can zoom in or I can zoom out. And if I am going to fix the size of the clipping window and moving across the object in a scene, that is, I am going to fix the size of clipping window. I'll never change this, but I'll be keep on moving. The example what I showed you at the beginning with the 4 objects, I can move the clipping window wherever I want in the scene. If I do so, then I'm going to have a panning effect. This is what the advantage we are going to get when we have the clipping window and the viewport in your OpenGL 2D viewing pipeline. So now you know what is zooming. I need not explain you what is zoom in and zoom out. You're already experienced with all those operations, not specifically with OpenGL program, but in general you are aware of this. But when I say panning, few of you know how the panning is going to be or how the panning happens, but few may not be aware. Hence I've just given you a small example of what panning is going to be. So right now this is my entire picture, what I have been defined or what I have been taken out. So now this is the first clipping window what I have been designed or decided. Now whatever the part of the scene or the picture is going to be in this clipping window will be visible. And now if I want to shift my view at the other side of my picture, I will just fix the size of the clipping window and move the clipping window to this location. So now this part is not visible and this part is visible right now. This is what we call this as the panning effect. Hence, so you can even work with the panning effect if you clearly understand how to control the clipping window and how to define a viewport. Fine. So now with this 2D viewing pipeline, so at this point of time you know what is viewing and what is clipping operation with respect to clipping window or a view window and what the viewport is going to be, and this you're already aware of. Fine. I had spoke about this in the earlier session. What are the different types of coordinates available? Fine. So just to brief out, whenever you're going to design anything in your computer graphics, these are the different types of coordinates what is going to be available. That is, you will take a sheet, you will put your object, you're going to design how the object should look, hence we call this as modeling coordinate. Once this is done, you will make sure this modeling coordinates or the modeling object what you have done, you will bring into the world coordinate of the OpenGL environment. Until this point you are not in OpenGL, you are still on your design sheet or the sheet or the page what you have used. And right now once you have done this and you are representing your object into the world coordinate system being in OpenGL environment, and once you are going to be in OpenGL environment, the objects what you have designed separately in its own modeling coordinates, now you have put in one unique world coordinate. And once you have done this, you need to subject it to the viewing and projection coordinate. This is the entire scene what I have been designed, and this entire scene what I have been designed should be put into the viewing window. That is what happens in the viewing and the projection coordinate. Fine. And once this is done, I need to normalize this. I need to normalize this with the device coordinate as well as my world coordinate. Whatever the coordinate values have been used here, it should be normalized. And once you're going to have a normalized coordinates, at this point from the viewing coordinates to the normalized coordinates, when I'm going to have projection coordinates, this is the point where the viewport will come into picture. And once you're going to have the normalized coordinates, you will directly map this with the device coordinate. The device can be a monitor, it can be a plotter, it can be any other output device. Hence, so just remember this, whenever you're going to talk about the conversion or pipeline of a graphic system, these are the different types of coordinate system what your object should pass through. I have been designed my object in modeling coordinates. I have brought it into the OpenGL environment into the world coordinate, and whatever I am going to have in the world coordinate should be projected to the device coordinate. If it should happen, if I should display these two objects in my monitor, I should go through all these coordinate systems. This is what happens in your 2D viewing pipeline. Fine. So now we will see what exactly happens in the pipeline. As I told you, this is what I have been designed being in my modeling coordinate. This is what I have been designed, and even I have been decide what should be viewed. So which this is going to happen at the time of viewing coordinate. but right now for explanation purpose I have put it at the starting stage itself. Right now I am just going to have these 4 objects, and these 2 objects should be displayed now on this device. Now monitor is going to be my device, hence from the modeling coordinate I need to bring my objects to a world coordinate. Hence, so to do this I am just going to use the modeling coordinate whatever I have been used, and I am going to construct using modeling coordinate. I am going to construct the world coordinate scene. So now when I am going to construct this world coordinate scene from the modeling code transformation, right now my objects will be in the world coordinate. This is the first stage what happens in the pipeline. And so once you have constructed the world coordinate, you have got the list of objects which is going to be in the world coordinate. Using this world coordinates, I am going to put it into the viewing coordinate. That is what the viewing coordinate is going to be. Hence I am going to convert the world coordinate into the viewing coordinate system. And once I have available with the viewing coordinate, so this viewing coordinate I am going to transform it to the normalized coordinates, because whatever the object I have been put into the viewing coordinate, this should be transformed into the normalized coordinate values. Hence we are going to have the world coordinate. From the world coordinate we are going to have projection coordinate, where we decide what part of the scene should be displayed, and the part what I have been decided will be subjected to the normalized coordinates. And once you are going to have normalized coordinates, you are going to map this normalized coordinate to the device coordinate directly. And once you have done this, you have got the device coordinate which you are going to display it to the monitor of the display device. Now this is what happens whenever you're going to have 2D viewing pipeline. Fine. So now this is the complete pipeline what happens starting from the modeling coordinate to a device coordinate system. And whatever the process I have been explained, the pipeline what I have been explained now, this is called as 2D viewing transformation. That is translating from modeling coordinate to the device coordinate is the 2D viewing transformation what happens. And this is also called as window to viewport transformation. So starting from the window coordinate or the world coordinate, I have been transformed to use viewing coordinate, which is normalized coordinate, to a viewport coordinate system. Hence we call this as window to viewport transformation, or simply I can call this as windowing transformation, because the modeling object have been transformed to a window object. And when I'm going to a normalized coordinate system, this coordinate usually by default is going to start with 0 to 1 value. The x value is going to start from 0 and the maximum is 1 of the x value, or the y value minimum value is going to be 0 and the maximum value of y is going to be 1, or in other case it can be the -1 the minimum value of x and the 1 being the maximum value of x, in the same with the y value in the axis. Hence if I take any coordinate system in normalized, either the coordinate system will be from 0 to 1 or it's going to follow -1 to 1. And once I got the normalized coordinate system, and before I'm going to map, this is where I'm going to have the viewport, and I'm going to have the viewport coordinate system. Fine. Now this is what you need to again understand, where the viewport will come into picture, because when I was talking about window or the 2D viewing pipeline, I never talked about viewport, but this is where the viewport will come into picture. Is it fine? And now, so once we are going to have the viewport, which is going to appear after normalization, and this is what I need to discuss about. So now just look at this. I'm going to have a clipping window being in the projection coordinate right now, and this is the point as an object which I want to display on the display device or the device coordinate. Now, which you cannot do it directly. You should go through the viewport coordinate only, and the viewport coordinate will come after the normalization. Hence, first step is I'm going to convert or translate or transform this point as an object being in the world coordinate to the viewport coordinate. If I want to do this, the mapping should happen. And this mapping is not going to happen only with the initialization or the assignment operation. It takes some formula to happen. And this is what the equivalent operation is going to be. I want to find what is the viewport coordinate value for x and y for the given point from the world coordinate x and y. Hence, I am going to have xv minus xv is the point what I want to find minus xv minimum, that is the point or the viewport window point. Find the x point of the viewport, and I'm going to say xv max, that is the xv max is the viewport maximum value minus viewport x minimum value. I'm going to have the similar with this case. I'm going to have x value of window coordinate minus x value or the x minimum value of this clipping window, that is xw min, and I'm going to have xw max minus xw min. Hence, clearly understand what this values is going to be, and similarly I'm going to do with the y values. Hence, now this is how the mapping is going to happen. And this form, if I simplify, if I'm going to simplify, I need to find xv here. I need what is xv here from xw. Hence, I am going to say xv equals sx into xw plus tx, because that is where some translation is going to happen, and the scaling is also going to happen because the object will be reduced, and the translation is where exactly I am going to place the object in the viewport. Fine. So now this has been replaced as yv, that is the viewport of y value of the viewport is equals sy w yw plus ty. That is the scaling factors and the translation factor, if you remember from the 2D transformations. Fine. So now you might be assuming what is this sx? From this equation, where did this sx come from, and sy came from, and where this tx and ty came from? Just look at this. This formula was simplified, and this sx, if I replace with this value, you can easily find how we are going to convert this. And the tx, I need to replace with this form. Just replace xx with this entire form and replace this tx with entire form, and now just check out the simplified form of this equation. You will get to know this is going to be equivalent now. Is it fine? So for simplicity we have replaced, and to show you that the scaling operation, the translation is going to happen, we have replaced this with sx and tx. Similarly, that is what happens with sy and ty. So sy is in this form and ty is going to be this form. This is what the simplified form of this equations is going to be. And now once you are going to have this form, now from the windowing coordinate to normalize viewport coordinate, the matrix what I want to have is going to depend upon the translation matrix, and I am going to depend upon the scaling matrix. I am going to have an composite matrix now. If you remember, I was using discussing about composite matrix in the earlier sessions. This is what the composite matrix is going to be. I am going to have scaling factor sx and yx. I am going to have translation factor tx and ty. Fine. And you know how this will be multiplied with this the original point to get the new positions of x and y. Fine. So this is what the matrix I'm going to use for normalization of viewport transformation. And this was the one mechanism how we are going to convert a windowing coordinate object to a normalized viewport coordinate object. Fine. So now just look at this, the second way of doing the same. So instead of directly converting from a clipping window coordinate or the windowing coordinate to its viewport coordinate as a normalized viewport coordinate, now let me put it into 3 steps. Now this is the second way of doing the same operation. I am going to have clipping window, I am going to have the normalized square as a normalized coordinate, and I am going to have viewport coordinate. The point what I want to transform is going to be in the clipping window, and I am going to normalize this, and I am going to put it to the viewport coordinate. I'll do it in 3 steps instead of doing in just 2 steps, because this will give a clear picture. Now just observe, when I was talking about normalized coordinates, I told you the x value can be 0 to 1 and the y value can be 0 to 1, or the x and y value can be from -1 to 1. And right now your OpenGL environment by default will use -1 to 1 system itself. Hence you can see the normalized coordinate system -1 to 1 in the x-axis, -1 to 1 in the y-axis. And so now the same sx value, sy value, tx and ty what I derived from the previous form, I am going to use the same now. Now when I am doing this form, just look at this. I mean the same composite matrix for the multiplication of the conversion from a windowing to a normalized square. Now just look at this, what I am doing here. The same form I am going to have, but now I want the composite matrix from window to normalization square only. And for this case, what I want to do in this form, if I replace sx with this form, you can just observe there is no viewport at all, because I am not talking about anything about a viewport. No, there is no any xv. There is no any xv. There is no any xv minimum, or even there is no xv maximum. And for this case, this xv minimum will be replaced with -1, and xv maximum and yv maximum will be replaced with 1. I am just going to replace xv max with +1 and replace this with -1. If I replace +1 minus of -1, it is going to be 2, and 2 divided by xw max minus xw min. Hence xx should be replaced not with this form but this form by substituting these values. The same thing is going to happen with sy. And for the tx, if I replace with these values, these are the 2 forms what I'm going to get. And this is what I should use the matrix right now. And with this sx, s value, tx and ty, when I want to convert the clipping window coordinate object as a point to a normalization square. Fine. So now the next step is I need to convert from normalization to the screen viewport. The same form I'm going to use, but I don't know what is xw max right now. I don't have any clear picture about this, and so now xw minimum and yw minimum should be replaced with -1, and the xw max and yw max should be replaced with +1. If I replace +1 minus of -1, this becomes 2, and this is the form what I am going to get. Similarly for sy and tx and ty, if you replace appropriately. So this is the matrix or composite matrix what I am going to use when I want to convert from mapping of clipping window into normalized square, or right now in this case from the normalized square to a viewport. That's fine. So this is the way how we are going to map from the windowing coordinate system to a normalized coordinate system. Fine. So now this is what is going to happen in OpenGL 2D viewing. So now just look at this. Now to do all these operations, so to set the viewport, to set the windowing, or to set the clipping window, or when this conversion all happens, how do you map? All these things you need not worry right now, because OpenGL is going to give you a few number of functions which is going to help you do all these things. That is, the basic OpenGL library has no functions specially for 2D viewing, because whatever the basic OpenGL library is going to have, it is going to have the 3D viewing operation, because the OpenGL is specifically designed for 3D, but by making the Z component as 0, I can use it for 2D viewing also. But just keep this point in your mind. And next, the core library contains viewport functions, because the viewport is going to be always in 2D. There is no 3D viewport. The viewport is going to be always a 2D plane. Hence, the core library will contain the viewport functions. And if you want a 2D clipping window, which is right now not available in the basic or the core OpenGL library, you can use the auxiliary libraries like GLU library, where the GLU library has a function for specifying 2D clipping window. Fine. And the GLUT library function has got few APIs which is going to handle the display windowing system. So now we will discuss about OpenGL 2D viewing functions in the next session. But make sure you remember all these concepts: what is a viewport, what is a clipping window, and so on. So in the next session I will discuss you what the functions you should use of OpenGL program to have all this operation. Fine. So this is all for this session. Thank you.